This is a model of the Hubble Space Telescope. I had to do some repairs on it due to the many places it's been. Let me take you on a tour of the telescope. The first part that's most obvious is this barrel called the light shield. Light comes in from the universe and bounces off the primary mirror, which is approximately at this level. This model actually has a little mirror inside of it to mimic that. So there's a primary mirror here, all the light bounces off of it, and because it's curved, it will all gather to a secondary mirror approximately here in this location, and then all will be collected in a beam about a foot wide that goes down the center of the telescope where all the cameras are. Now these doors open up to allow access by the astronauts to change the cameras. Like over here, these doors will open up and the cameras inside were changed out. When it launched, it used to have a camera called CoStar, but now it's got the Cosmic Origin Spectrograph, COS. And this one has advanced camera for surveys now. So going back up to the top, let's start from the top. This is the aperture of the telescope, the opening. And this is the aperture door that closes in the event of emergencies. Pointing the telescope at the sun would be fatal, and so this closes on emergencies when we accidentally point it at the sun. So that's never happened before, but that's what it's for. As I said before, there's the light shield as you go down. Next to the light shield, there are these two microwave antennas. One is up like this, and the other one's in the deployed position, and they are used to send the images back to Earth. It runs at a very slow 1 megabit per second, which 35 years ago used to be very fast, but now it's pretty slow. These are the two high gain antennas, this one in the stowed position. Up here you see this bar, this is the torquer bar. There's 4 of these that we use to move the telescope around by pushing against the Earth's magnetic field. There's another one here. And as I said before, down at this level is where the mirror is on the inside. And we also have 2 levels of electronics that run the telescope. One thing I forgot to mention is that there's one side that's always facing the sun, and that's this side here. This side faces the sun. So the sun is always on this side, and that's why this telescope aperture door blocks the sun. And this side is the shady side, is the cooler side. It's in the shade all the time. You see, this is the second layer of electronics boxes. For example, this says FGE. This is the Fine Guidance Electronics. That's in bay F, and so forth. And these are the lower bays. Over here we see the batteries. Batteries are bays 2 and 3. These have little louvers on them, little windows that open up to keep the batteries cool, because again, this is the shady side. Let's look around a little bit more. These are the various computers that run the telescope. The DMU, Data Management Unit. We see SIC&DH here, which handles all the data from the science instruments, from the cameras, as all processed by the SIC&DH. On this side, we see 2 of the 4 reaction wheel units. These heavy wheels spin to orient, to move the telescope around. The telescope does not have rocket motors. We use motors, electric motors, to torque the telescope around. These bays all have numbers, so that we know where they are. And I got this model as one of the system engineers so I could quickly tell where everything was. The next layer down are the fine guidance sensors. We use stars to track where we are while we're taking pictures, and the fine guidance sensors lock onto stars and allow us to keep the image very steady. Then lastly, on the bottom, as I said before, are 4 cameras, 4 science instruments. This one is a spectrograph, STIS, and this one is a NICMOS, the infrared camera. Now, one thing I've added here is the radiator. This radiator was added at a later mission, and that's why it's stuck out like this. And on top of it, we have the ARUBA box. And this little piece represents where the ARUBA box is. It's in the shady side of the telescope. And last but not least, we have WFPIG 2 here, but in the actual Hubble, it's been replaced by Wide Field Camera 3. This is the big camera I worked on many years ago as electrical lead, and now it's the main camera that we use on Hubble. It takes most of the images. And down here we have the star trackers. These are cameras also that look out and look at the stars, and it can tell based on a map where Hubble is, which way Hubble is pointing by looking at the stars. So here we're back again around, this is the batteries. Another notable thing is these round circles is where the the shuttle robot arm grabs onto. When we were serviced by the shuttle, the robot arm would reach out and grab at these 2 points, one of these 2 points, and then it would fasten it and put it inside the shuttle. Just like this. This poster shows how a shuttle would grab units and put it into the cargo bay. Well, this is what this feature is for. And this was a tour of the Hubble Space Telescope. I hope you liked it.